Yeah.
Oh, Bristol. Oh, very good. Good place. Really good. Nice place. I love Bristol. What was your PhD in?
I'm modeling in architecture.
Oh, okay. Yeah.
Nigel maybe.
Nigel Smart.
Subramaniam is there, right? From Bristol, he moved to Mumbai.
Yeah.
HCI.
Yeah. Nigel, I know well. Yeah. He's now at Zama. No, he's chief scientist. No, he moved from Bristol a long time ago. 8 years ago.
Oh,
Maybe 7. He's at KU Leuven.
oh, no.
And if you know Nigel, Kenny Patterson was at Royal Holiday. He's at ETH. Yeah, they both moved. I think he's at ETH, not EPFL.
ये देखो एक नई भेजा है जो देखा हूँ लिंक भेजा
Have you got?
अच्छा क्या है या अपनी सेवन
Have you got a bit of spray to clean? Because this is not very well.
हाँ बोल दे ना
No, I want to rub this off so I can write again.
Is there a liquid out there? He will take care.
You take it here. No, he will not start now. He
will bring some.
Okay,
I
thanks.
delayed for you, right? It is just. Yeah, relax for some time. Exam. What? This is transfer.
He not able to download.
Yeah, I don't know. You will download it somewhere else. Yeah. Only one spider. Security. Have a cup of tea? Please.
Yeah, but tea like.
Please. No. Take a cup. Take a cup of tea. Yeah. So what I do is that. I followed it, but I don't know whether you can do or not.
Yeah.
I told him to download. Oh, you might have not understood what I said. Yo, hey, this coffee thing? Yeah, the black coffee. एक कप पे यहाँ पे another again. हाँ ले लीजिए ना. दो मिनट black coffee लेके आया.
Sorry, it's black coffee.
I won't. Thank you. Yeah. सर चलाइए डायरेक्टर है ना डायरेक्टर से बातें हुआ है जब डायरेक्टर थे तो प्रॉब्लम क्या सर ग्राउंड में सत्येंद्र को नहीं है हाँ वो देखिए डाउनलोड कर लीजिए अभी कभी कभी नहीं सारी लेके मैं अभी डाउनलोड किया भेजा आपको दो मिनट You have to send this, you know. Not a hurdle. You have to send this. Yes, it's back. तो लेके आओ ना अरे पार्टिसिपेंट का लिस्ट नहीं दिया मेरे पास सीट है हाँ इंडिया चाहिए मैंने सीट को नहीं कर सीट यहाँ पर सीट बन देता हूँ हाँ उसमें जैसा है नहीं बोल रहे हैं अब कोई जो आया नहीं कहा है नहीं नहीं किया नहीं हो रहा
उसमें शायद नहीं होता है इधर करना पीछे वाला
चलो नहीं
देखते कभी भी नहीं काम करता
Sorry.
अभी
वो जो पीछे वाला पीछे वाला का पीछे यहाँ इधर
You got it? So this one?
Opening.
Sorry, just one sec. Sorry. Don't open it yet. I don't need it yet. I'm still on this one.
स्टोरेज का सिस्टम के लिए हम लोग लिख सकते हैं कि जो whatever model points are there, please use the same as model point. Okay. वो हो गया.
Okay, sorry.
वो भी नहीं आपको सेटअप कर देंगे.
Okay, shall we start? Okay, super. Right. So I'm just going to give a little overview of some of these things that are changing. So the first is artificial intelligence. And the first point to say is actually sometimes people split this up. Yeah. Okay. Sometimes people split this into security of AI and AI for security, yeah? Because AI has got such a fundamental impact. Now then, what we've already seen is AI is not new in what we call defensive AI, so defensive security, okay? So you've heard of SIEM machines, I'm sure, yeah? But any kind of intrusion detection, any kind of intrusion protection scheme, yeah? Firewalls, yeah? All those, many different malware analyzers, many different systems, yeah, have AI in and have had for a long time. There are some newer techniques that are particularly happening. And I'll show you some a little bit later on in the courses as well. But one thing that's particularly of interest is reinforcement learning. Yeah, so we had a project recently called Reinforcement Learning for Moving Target Defence. That was funded by the UK Ministry of Defence. Yeah, but reinforcement learning. Right, so I'm going to test 430 and see who's awake, because everybody's got to put their hand up right now, right? Either yes or no. Who's heard of reinforcement learning before? Put your hand up. Okay, roughly half. And who hasn't heard of reinforcement learning? Okay, now that didn't look like everybody put their hand up. Yeah, it's really simple. It's binary, yes or no. You've heard of it or not. So we'll try once more. Put your hand up if you've heard of reinforcement learning. Okay, well, so now I know a lot more of you. And your hand up if you haven't. Okay. Have you heard of it or not?
Yes, I can.
Okay. Is my accent difficult? Okay. I speak with a Manchester accent, so sorry. Okay, reinforcement learning. Of course, reinforcement learning is all in the news now, right? Why is it in the news? Anyone know? Exactly that. Straight in that. DeepSeek. Yeah? So you all know that DeepSeek has got reinforcement learning, but reinforcement learning is quite an interesting technique, been around for a little while now, and it's really helping on defensive operations, especially reinforcement learning with human feedback. Okay, so where you get to do some reinforcement learning, but it's learning from the human as well. So what happens is with reinforcement learning, it will typically just, you know, the big one was AlphaGo, right? Yeah. But with reinforcement learning, it plays lots of scenarios, lots of games, yeah, and it works out what are the best policies, what are the best strategies. So at any position at any time, so in terms of networks, yeah, what it does is it says, I've got a network state right now. What is my best move from this point? Yeah, it is really non-trivial, because what you have to do is it's really complex, because sometimes your strategy has to be, what's the ultimate goal that you want? Is your ultimate goal to defeat the attacker? Yeah, or is it to wait long enough, so play so many moves, yeah, because you treat it like a game, yeah, that they exhaust all of their resources. And that's one thing you should be aware of if ever building a network system where you're trying to protect it, yeah? One of the things is it takes resources from an attacker and a defender. And sometimes the attacker's resources can be much more, especially if that's a nation state or something like that, yeah? And they really want to compromise something. Other times, they might be able to launch something that's very low effort, yeah? So what they're doing is looking at what it takes you to defend, yeah? And sometimes, so I was at a conference where the UK government, National Cybersecurity Centre, GCHQ, and the NSA were talking about some attacks in America, yeah? And these were attacks from Russians on the financial services industry, yeah? Now this was unusual because the attacks were not designed to get income. They weren't bothered about that, actually. What they were doing is trying to subvert the efforts that were supporting the Ukrainians in a cyber war, yeah? So all they were doing is tying up resources. They weren't trying to really compromise, they weren't bothered. But the Americans couldn't take that risk because financial services are part of critical national infrastructure. So sometimes these strategies are to utilize resources. So that's what's really important. If you're going to use reinforcement learning as a defense mechanism, some of the newer forms of AI, yeah, then you have to be careful how you set the policies. Of course, one of the things, so that's really good for us, right? So AI is helping us now because we can get lots of intelligence, yeah? In fact, that's one thing as well, the use of AI in cyber threat intelligence analysis, yeah? So if you have got, you know, an open CTI or a MIS or a Sentinel or some kind of Splunk kind of service where you're looking and analyzing lots of data, we have to turn that into information. Yeah, so we have to look at what's happening on our network and what's happening globally as well. Yeah, so AI can help us a lot with that, but unfortunately AI is also very good for the attacker. Okay, AI is getting much better at helping support those reconnaissance tests, you know. So, you know, it used to be really easy to find out bits about a system because sometimes you'll release what version of the system is running on a service or things that you're doing, are trying to analyze, so collect that data. But now that data collection can get a better analysis of your system. They can also get using just like LLMs. I've got a paper that we're going to be submitting soon about how LLMs can help in cyber defense, but they're certainly using LLMs in cyber offense, if nothing else, to give you a new, different area to try that somebody might not have thought of as a human. So we've got a problem with offensive AI. And then finally, around the impact. So AI is having an impact on cyber operations, both defensively and offensively. But AI, writ large, all of the AI, not just the AI in that cyber operations, but the AI is a risk itself. Okay, so from sort of attacks that we've seen where you're trying to break guardrails, yeah, through to some much more serious compromises of AI. And we should be aware, you know, that there are things such as side channel attacks. Yeah, these are very interesting and increasing, and I think you probably know about this more than me. But I remember I was visiting Columbia University a couple of years ago, and you know, there was some really interesting attack where it would work in a data center. You put a magnet around the cable, and it would give you the architecture of your neural net. Not necessarily the weights initially, but it would give you something. Once you got that bit of knowledge, you can then apply other techniques. So securing AI is something that's actually, that's a real problem at the minute. The only bit of good news around that is that, first of all, in CNI, critical national infrastructure, they're very risk averse to putting AI in. Yeah, so we're not as likely to see compromises on the most important assets that we've got. But so that's one bit of good news. And the second bit is we're still learning how to create vulnerabilities in AI at the moment. So the good news is that, you know, the attackers haven't got a lot ahead of us yet. That will be an increasing battle. Another thing that's really developing is zero trust architectures. So I don't know if any of you have heard of zero trust architecture. How many of you heard of that? Put your hands up. Not many. Okay, I'm going to trust you this time. Now I'm not going to ask everyone to put their hand up. Okay. So zero trust architecture. Just let me say it first. So zero trust as a term was around a long time ago, early 2000s. But zero trust in terms of an architecture was a researcher at Forrester, John Kinderberg, who came up with the zero trust model in 2010. But it is interesting because this work has been around in sort of defence and military for quite a while. And where it comes to, so I'm going to stand here. When I became a professor, so I was first became a professor in 2004, a long time ago, right? And when you become a professor, you have to give what's called an inaugural lecture. Your first professorial lecture, and it's a public thing, and people from many universities came there. 300 seat auditorium, about 200 people were in it. And I stood behind a lecture pretty like this, yeah? And I talked about the changing nature of security. And what I said is, when I started doing work in security, wasn't that much earlier actually, it was only 6 years. I got promoted quickly. But what I said is, at that time, 1998, you know, you could just box off your system, right? It had this perimeter. It was nice and easy, yeah, to protect. But what started happening, it became more porous, more people having access. In fact, I should tell you that in the early 90s, people that had Linux servers and that weren't putting passwords on them. They were just locking the door. It was physical security, right? So yeah, back in those days, email would be encrypted, yeah? And yeah, I remember at university sending an email to someone else. There was no computer misuse back then, but I sent it to someone else pretending to be the warden, the whole warden where we lived. You could just change it, it's so easy. Anyway, this is what it used to be like in 2004. I said it's just starting to change. You know, this perimeter is going. I use that term, and deperimeterization was a term that had just started coming out at that time. So this is a different way of thinking about protecting assets, because what you used to have, yeah, was this was your trusted zone. Anyone who was in here, yeah, It's okay, you've got through, you've used a password, you've got some asset, you're in, off you go, help yourself, yeah? And I might have some access control, yeah, some authorization, yeah? But basically, that's your playground once you're in, yeah? And we'd say that's good, because we've got this perimeter, yeah? And what you do is you just say, all the bad guys, we just keep them outside. And that was the way that we used to do things. But we started moving into this sort of people saying, well, trusting everyone is a vulnerability. Yeah, you're encouraging once they meet that threshold, you've then got a real problem. So so trust, the vulnerability, and deperimeterization were the two things that people were working on. So John came up with this zero trust architecture, which a few years later turned into a NIST. So that's the National Institute of Standards and Technologies in the US. Yeah, and there is a NIST special publication 800-207. That here again, you know, we talked about AI. So here you've got your enterprise system. Here your SIEM that manages incidents and events. Yeah. Your sort of ID management, public key infrastructure that you need, a data access policy, who can see what, yeah? And what's really important and interesting here is on this side, yeah, you've got threat intelligence that you're starting to, so this was really trying to see, how does the threat and how does the behaviors of my system change what I should do? Yeah, so what you end up with is now if somebody, the subject, yeah, has a system and they want to try and get to a resource, yeah, and this was all the thing, protect all of your resources, don't protect your perimeter, yeah, protect your resources or your assets in this. So what you would have is you would have a policy enforcement point. So when a system came in, immediately do not trust. Ask them for things, ask for credentials, yeah, and this is why sometimes you might be asked for two-factor authentication now than you weren't before, yeah. But look at the environment, yeah, get this threat intelligence, have a policy engine, this policy decision point, yeah. The administrator is not the person, it's a function. And what you do is you enforce the policy, yeah? So this is much more dynamic, yeah? So access control mechanisms, there's a number of different access control mechanisms, but role-based access control is one thing that's been developed and it's used quite a lot. But that basically says, what can you do based upon your role? And now we're moving to attribute-based access control. Actually, it's quite a bit harder with attributes, because what I'm saying is, tell me specifically, not just because you're a professor, can you access all of this? Tell me why you need to access all of this, yeah? So what have I got that's competent? What attributes have you shown to me that you need access to this? So it's much more finer grained, it's more difficult, because of the fine-grained nature rather than the roles, but you end up with something that is dynamic based upon your threat intelligence and the current activity on your network. Yeah. So if you start to see more people trying to access certain resources, then adapt to that. Okay. So the zero trust architecture is now being rolled out. So it was, yeah, 2010 when John came up with this. He gave a talk on it in about 2012, really. That's where I started noticing about it in 2012. But it was only in about 2017, I can't remember when the NIST publication came out. It was 2017 where people started saying, okay, let's start implementing this. It took a little while to get going, and that's because it's a little bit complex and it needed a rethink of your security architecture, and in some ways it needed a rethink of your data architecture as well, your system architecture. So yeah, here are some of the things that are part of that. So what you've got is device identification, and you'll know, so I think you've heard, I lost my phone recently. That's terrible because that is used, you know, I use passwordless logins for the United Nations, yeah? All they do is they say, have you got your phone? And then we know it's you. I cannot go to an organizational login for the UN, yeah? What I have to do is go to log on and it will send something to my phone and that's been verified. And that's a manual kind of thing. I have to show my passport and my face, do it and set it up with the person one-to-one with my phone. I'm going to have to do that again now because I don't have that phone, yeah? So device identification is becoming increasingly important. Excuse me while I sit down for a moment. So if you want to have zero trust, you need to think about identifying those devices. Is somebody logging on from a different device? If they are, ask them to do more, yeah? So then you've got user identification. So the dynamic authorization is the point I mentioned, that because of the threat intelligence that you've got, be dynamic in what you allow access to. And zero trust is one of the biggest drivers for multi-factor authentication, okay? There's still some problems with multi-factor authentication, but not as much now. But one of the things you should think about with multi-factor authentication is, you know, it is possible to have a man-in-the-middle attack. Because all you need to do, yeah, is, well, sorry, not now, but you used to be able to, because you used to put it into a browser, yeah? And when you had to put things into a browser, that's not so good because that page, you don't know if that page is the right page. What we've got now is trusted execution environments that we know that when you go to the authenticator apps, they are secure for multi-factor authentication. Yeah, and what you do is secure communications. So wherever you are, all of the communications, so where you have that trusted zone previously, you'd say, I'm going to secure all communications, yeah? And that makes sure that you've got the same level of security verification and authentication, whether you're in the network or outside the network. Policy fine-tuning is about when you've got your policy, don't keep your policy fixed. Think about how you adapt that to work better for your organization and to use the insights from all the data points that you've got. I showed you up here. So you've got a number of sources of data on here. Yeah, you've got threat intelligence, you've got your SIEM, etc. Activity logs. From that, yeah, fine-tune your policy. And then finally, as I said, attribute-based, yeah? So moving away from role-based access control, think about the attributes, think about the location. Some of you will know this, but actually, many companies now insist if you've got your own device or bring your own device, if you're going to log on, you need to have certain versions of software on there, including operating systems, yeah? Because that helps decide what your, because that is an attribute of your device, right? So those attributes of the device, those attributes based upon what you've been doing, what's your behavior been from the device, yeah, will determine what level of trust you need in the system, yeah? So again, this is about trust, right? It's about the system having to say, right, well, you've got some attributes that you're going to have to convince me of. And you say, well, okay, I've got this level of software. Okay, that's nice. I've got this kind of behavior that I've been doing. Well, yeah, nothing out of the ordinary there. And they are ways where you, actually this time the user, is showing its trustworthiness to the system. And therefore the system can make a trust decision. Yeah? So it's a nice little coming around from what we had before. Okay, any questions on any of that? No? Okay, next big thing. So maybe I'm cheating here a little when I say this is a big thing in the emerging and future, because it is. It's just the next thing I'm going to mention has been emerging for 10 years, and more than 10 years. For a long time, we've said quantum computing.
In the previous slides, you fine-tune based on the upcoming threats.
Yeah. So you do that analysis, and that can be predictive. Yeah. So you can be reactive or predictive, but if you're predictive, that's more maturity. So I think this is one of Google's quantum machines, but quantum technology. So I know somebody who works in the field, and there's two different fields of thought right now. Somebody's saying we're really close to a massive breakthrough, and but actually the biggest guy who said that has had to retract a little now because there was an overclaim. But there are a number of people who say just to get the supercooling that we need and the number of qubits, so the number of qubits has gone up quite a bit. We're still nowhere near where we need to be. In fact, I might be able to give you some information on that in a moment. But so quantum computing, it exploits quantum mechanical phenomena. So you will know at the quantum level, and this has been proved by people, and this is where you had the Young's double slit modulus, which shows, light moves in waves. So for a long time we all thought light moves in waves, great. And then what we saw is, hang on, no, it doesn't. It moves in quantum. And then we said it doesn't move in quantum in chunks, in pieces. It moves in both. And this exploits quantum technology exploits those physical nature. So it's completely different to sort of our current computer architects. And again, you should stand up and talk about this instead of me.
Yesterday, Microsoft released quantum chip.
Did they? Wow. They released it. Interesting. So I missed that because I was busy yesterday. But the thing is, it's a different hardware, right? So I'll have to check the news on that. But basically, you have these qubits and you've got a superposition of states, So what you have is a probabilistic outcome of the state that a qubit is in. So there are some people think, it's in both states at the same time. It's not. There's a probabilistic thing, but they are superimposed. It's superposition. And actually, this helps with the calculations when you compare to a classical bit. But it's not that it can do 0 and 1 at the same time, so that's why something linear becomes, something exponential becomes linear. It's not quite that. But one of the things about quantum computing that's going to have a big impact is around integer factorization. So first of all, we've got someone who knows about architecture, so we've got someone who knows a lot about cryptography here. I'm going to bring it back a little, but one of the things is what we've got problem is there's cryptography, public key cryptography in particular, relies on a problem, a one-way function, something that's hard to do one way but easy to do the other. So something that's easy to encrypt, but without a key you can't decrypt it. So public key cryptography systems largely rely on something called integer factorization. It's about taking two large primes and doing something with them, right? And essentially what people want to do is find out what are those two large primes. That's what now, the reason I say the public key is because actually that is not how symmetric key encryption works. Yeah, symmetric key encryption works on a number of things, but it's got substitutions in it, it's got transpositions in it. Yeah, it doesn't have integer factorization. Okay, but most of our stuff is based around RSA from Ramesh Samir and Adelman, and this is a big problem. And it was not a problem until somebody came up with a specific algorithm. So, in the interest of time, I won't go into the algorithm, but we'll see. I'll give you the slides, but you can look up Shor's algorithm. Yeah, but what you do in Shor's algorithm, it's not all got a quantum variant. The first part of Shor's algorithm you can actually do on a classical computer. Yeah. So what you do is you reduce this factorization to finding the period of a prime. Yeah. And that reduction can be done on a classical computer in reasonable time. It's not exponential, that. But what quantum computers can do is using that point I said about the superposition and the probability, you get this quantum parallelism, yeah, and you find you have a quantum Fourier transform, so a quantum version of the standard Fourier transform that allows you to have this quantum parallelization. So it required an algorithm from Shor, yeah. Oh, in fact, I haven't put the notes on that. Anyway, oh, I have some notes, yeah. I won't go through it all now, but I'll maybe send that to some. It's also on the slides on the notes. But I'll walk through it. How you do the quantum, well, how you do all of Shor's algorithm, actually. But I do want to go on to another element, which is quantum key distribution. So quantum key distribution, everyone heard of quantum key distribution? We use this now in the UK. So the leading company in quantum key distribution is BT, who's formerly British Telecom. BT have got a large science park at Adastral Park, yeah. And what they do is they use quantum keys, yeah. Now here, what you're doing is you're taking the principle of quantum mechanics, which is Schrodinger's principle. Yeah, so Schrodinger's cat, you may have heard of. Yeah. Schrodinger's principle is you cannot observe a system without interacting with it. And that's why Schrodinger's cat, it's got this superposition, right? Because is the cat dead or alive? Well, it's both. Because you cannot tell until you open the box. And if you open the box, you've interacted. So the question is it dead or alive after you open the box? That's not the question. Is it dead or alive right now when you haven't looked in the box? Yeah? So quantum key distribution is a new approach. So we had a large project doing something called Air QKD. This is sometimes called free space quantum key distribution. Okay? So free space quantum key distribution meant we were doing it over the air, not through fibers. Okay? So BT has got a large haul coming out of Adastral Park in Ipswich, going to at least Cambridge and then some others. I think they've done like nearly 200 miles of distance. Yeah? And what you do is, the important thing is that you must have, whether you do it over the air or in a cable, you must have a classical channel. Yeah? And the reason is the quantum key channel, the quantum channel, is not fast enough. You can't do it in time, right? So the quantum channel, yeah, is not used to transmit information. It is used to transmit only the key. Yeah, and I'll tell you a little bit. So still, there's an algorithm back from 1984 called BB84 that's typically used in these kind of systems. But what you do is you start with a quantum channel here. So what you might have is some light source, some photon emitter, right? So Alice has one of these, and Bob has a receiver. Now, first off, these are not cheap. yeah, for and certainly not for over the air. Okay, so the ones that we were looking at, a pair cost about £100,000. So yeah, a lot of money. So with the quantum, what happens is, yeah, you send these phased quantum bits. As they go over, yeah, they're received. You've got a receiver. Now, what it relies on is a probabilistic proof, because what you do is you get effectively some readings, yeah, and what you're doing is saying, how many do we agree on, yeah? Now, if somebody was in the middle, an Eve in the middle, yeah, every time they were reading one, they could read some of them, yeah, but probabilistically, if Eve was reading them because they're interacting, you would end up with no agreement at the side. So actually, what Eve can do in this, and it's a bad thing, is disrupt the channel, yeah? But they could do that with a classical channel, right? Just by it's, you know, putting some signal jammer in, or but Eve can disrupt the channel because keep perturbing all of the quantum bits. But what you do is you use a probabilistic argument to say, okay, I've got sent this many bits, yeah? This is what I think they are. And if they match sufficiently, you say it's unlikely, highly unlikely, that it's a different, somebody who, it wasn't Alice or Bob who received it, okay? So that's in the quantum channel. You then simply take that and convert it into a digital key. Okay, so in the classic domain, so you get a key, 0s and 1s, yeah. Get a key that you've both agreed on, and you know that nobody has tampered with it in the middle, to some high degree of probability. Okay, and you can set that. Now, what we've got is the key agreement. Yeah, so you've got key agreement now. So what can happen is Alice and Bob can simply use that to encrypt and use the classical channel, but they're now using, instead of having to use public key crypto to get a key agreement, they've used quantum channels to get the key agreement. Now they can use symmetric key encryption, and that is not quantum vulnerable. Okay, so it is quantum resistant. If any of you've seen, AES has got, it does suffer a little. NIST does have a list of the impact of quantum on different algorithms, and AES is affected, but not significantly at all. It still remains secure. In fact, they classify how long things are secure for or insecure, if they're insecure already. Okay, so that is quantum key distribution. I'm just going to go through for a couple of minutes onto another presentation, but I'm happy to take any questions on any of those emerging trends, questions. If not, let me go on to the next topic. And we've talked a little bit about different facets of trustworthiness, but what I want to talk about now is that security is not enough. So I've been working, in fact, we still call the cyber systems and cyber secure research group because that's what people talk about. But the fact is, for many years, I, with a bunch of others at Bristol University and at Thalers and a few other places, have said security is not enough. And this started because the director of the National Cybersecurity Centre in the UK came to the university, and we were having dinner and having a chat, and he said something that I've been thinking for a while, and he said it the next day in a talk, a very public talk, and said, the question is not, are you going to be attacked, or are you going to be breached, sorry, it's when are you going to be breached, yeah? And this was about 2016 or so, and it aligned very much with the work I was doing, because what we started saying is, hang on, security is not enough. Security is very much about preventing and protecting. Yeah. So protect the confidentiality, protect the integrity and the availability of the system, keep people out, very much on protecting. But that's not where we're at, because people will compromise your system. The question has to move to how do you react when compromised? Yeah, how resilient are you? And that's what we started working at. So I think somebody said, maybe you, it was on there, changing attacks, right? Emerging attacks. Yeah, you said it when we were looking through the cloud thing. So this comes in handy now, because I'm going to talk about these changing attacks. So the first thing is, here what I'm saying is, we've got to bring your own device. I talked about that before. We've had that for a long time. Actually, for that, when I work with HSBC, I largely have my own laptop. Just keeps it a bit easier for me. But and when I work with Financial Conduct Authority, I have my own laptop. But when I work for the UN, I can just use my own. So the thing is, sometimes bring your own devices, you know, but they're all, you know, there's a mix then of proprietary devices and bring your own. But the thing is, if you have proprietary, means that you can't take them when you go anywhere. You know, it just becomes a little bit more difficult. And it's difficult for me to have 3 laptops if I'm doing work on multiple things. So the better thing is bring your own device. But your problem with that is, how do we manage that asset? So actually, this is a managed asset actually. So this has got something called GIAN on it, but there's different ways. There's certain things, as I mentioned before, with zero trust, because it's my own device, that I can't access certain services. So bring your own device is an increasing problem. Yeah. We've then got this is demonstrating. So it's a wall with lots of things through it. This is because it's a porous perimeter, okay? So you've got this boundary now where you've got lots of ways for people to come in and out, okay? And that means we've got a greater risk and a little bit more to manage. This represents the Internet of Things. So we've got more things, we've got more sensors around, etc. But coupled to that is something called operational information technology convergence, or OT-IT convergence. And that's because, you know, the network that we had, which was typically to get onto the computer and things like that, is now converging with the heating, ventilation, air conditioning. Yeah, it's combining with everything now, and you don't want lots of different networks, right? So you can have some segregation, but effectively, we're now seeing a convergence of the operational technology, so we can have much more intelligence, and that requires IT. Okay, so that will include cameras as well and sensors for how many people are in a certain room, etc. So that OT-IT convergence is creating a new challenge. What we've got, and I've mentioned it already, is we've got state actors. So that's the image. Oh, the image on the top left there. State actors. We know that the Russia-Ukraine conflict that's going on now, that's not the first time there's been a cyber element to Russia and Ukraine. You all know about the power plants going out and for a significant time, quite a few years ago. You're talking about 7 years ago or so here. I think the power blackouts in Ukraine was like 2017. But before that, there was also a cyber conflict in Georgia. So again, the Russians, but not quite as significant. So you've got that. The image on the right is something that's pretty worrying. I was working with the UK government just just last Friday, I think it was, no, last Wednesday, talking about the impact of AI on cybercrime. And what we're seeing is cybercrime as a service really increasing. So while we talk about nations, groups that are mercenaries, and they can be hired by either very rich people or nations, etc. The interesting thing about cybercrime as a service is becoming very much like that service model, where people move between organizations, organized crime gangs, yeah? And what that means is you're getting knowledge shared between these enterprises. So it's becoming really challenging to address that. As well as cybercrime as a service, you've got commoditization, yeah? So it becomes a commodity, these attacks. So attacks are actually developed and shared. And that's happened quite a few times. When I wrote in 2010 something called the UK Security Breach Investigations Report, it was done in conjunction with the Police Central E-Crime Unit in the UK and an organisation called the Serious Unorganised Crime Agency. They're both part of the National Crime Agency now. But one of the speakers stood up and said, our challenge is that we are fighting organised crime with disorganised crime fighting. And what he was talking about there is that people are building tools and then they're sharing them or selling them or trading them because there's more than enough targets to go around, yeah? And at that time, as I said, there were two agencies there, and what you were saying is we're disorganized. Part of that, a year later, became the NCA, the National Crime Agency, so that in some ways was designed to overcome those challenges. So what we've got is increasing attacks across all areas. Education, it's like the domain that we're in today, is increasing. I should update these slides actually. This was from a couple of years ago or so. But you're getting increasing number of attacks per organisation. And this is, you know, this is just over 2021 to 2020 to 2021, so the start to the end, so a 2-year period. You're seeing about the global weekly cyber attacks per organisation being from around 530 to more than 930, so a significant increase there. You're talking about, you know, 70% increase, yeah, and those figures are growing the same. You can see here, software vendors getting much more attacked, a big jump of 146%, but universities or education and research getting higher as well. So we're seeing increasing attacks, and we're seeing the rise of ransomware, yeah? And ransomware is, in fact, there's double and triple. So what we're seeing in ransomware, and in fact these figures will be much higher than this now, because last year it was the biggest single contributor, ransomware. But what we're seeing is we're seeing double and triple exploits. So the first thing that the attackers do is they compromise your system and lock it up, okay? And then they charge you a ransom, and then you may pay the ransom, and they may not do anything, might lie about it. But the other thing that they're doing now is they're going into, so you've got a double hit, right? You've paid a ransom, you've not got access to your system or your data, and then they've released it anyway, okay? So what they do is they give you, first of all, the first part of the ransom is you get access back to your system. Second part is, so this is why it's double exploit, they say, oh, by the way, we've still got access to, you know, we've got all the data. you're going to pay us more money now, or we'll dump it publicly. And people have done that, right? We've seen dumps. Even though we've seen it, the advice is not to give in, because you don't know what they're going to do anyway. You don't know who you're talking to, so they might just dump it anywhere. So we've seen those dumps you get done there. And then the third one is, yeah, well, we're going to tell all of your customers, yeah, we're going to tell them any information that you had on your customers, and we're also going to tell them that you were compromised. So even if you pay, right, so you pay to get your money, your system back, you then pay so that they don't dump it, and they go, okay, thank you, and we won't dump it. Oh, but by the way, we're going to tell, we're not going to dump, but we will tell your customers, because we know who they are, that you have been compromised, and we've got the data, unless you pay us a third amount of money. Yeah. So ransomware is very many big attacks in the area. Interestingly, you see that, I think, where was retail? Yeah, retail was up about 40%. But as well as that, the cost of cybercrime is increasing hugely. So what we're seeing is a massive global cost. And I'll probably try and get for you tomorrow some new figures on this. But also the cost of a data breach is increasing. Yeah. So this is on average in 2021. Yeah, 2021. It costs 4.25 million for every single breach that happened. Yeah, on average. One thing is, it has seen the rise of something new called cyber insurance. So actually, cyber, it's been going about 4 or 5 years. My former student is actually the head of research and chief technology officer at a company called Coalition. Coalition are valued at well over $1 billion. They insure lots of companies, and they're very active at insuring companies, but also ensuring that the company doesn't have a breach. Okay? Because the cost of a breach, actually, so if you know any companies that have had a breach, it is significant, because it's not just about gaining access back to its original point, right? Which is important for cyber resilience. But it's also the costs of the marketing, the communications. You've got a lot to handle. Yeah. The British Library was attacked 18 months ago now, nearly. Yeah. Still is not functioning. The transport for London system was attacked more than 2 years ago, and it's only about 3 weeks ago I could put a new credit card onto my Oyster payment system. These big organizations with decent sized budgets just really struggling to overcome the major challenges. And this is the kind of attack. So you can see that business email compromises quite a small number, but very expensive. Surprisingly, and in fact, if you want to look at how something's static, surprisingly, cloud misconfiguration, nearly 15% of all attacks were from cloud misconfiguration. And not just cloud, but if we think, if you look at the OWASP top, you'll see it's remarkable that SQL injection type cross-site scripting attacks are still there in the top 10 for goodness knows how long. So one thing is that I suspect may have changed recently is malicious insider. So malicious insiders, I think that is going to go both more expensive, hopefully zero trust kind of approaches will help us, but also it's going to get more prevalent, and it becomes more prevalent because of the economic turmoil we're in right now. So a lot of people, there's high interest rates all around the world. It gives people more of a reason to enter into illegal activity. And actually, insider threat is one of the easiest things. Just be a bit loose with your password, for example.
How about social engineering? What is that?
Sorry?
Social engineering.
Here's social engineering. Very small number it was.
What kind of attack is that?
Oh, social engineering. Social engineering. So a malicious insider is somebody who's being deliberate, but social engineering is where somebody tries to get your password out of you.
So phishing is here.
Sorry?
Like phishing.
It's like phishing, but not quite the same. Social engineering is just finding out a little bit more than you. So you could say, it's a bit speared part of phishing, yeah. But phishing is separate on here because they put it right up there. Phishing is typically rather blank. Spear phishing, you'd say social engineering or any other things. Now, here's one thing I did want to share because the percentage of the total cost, so this is the cost, yeah? So people will initially think, oh yeah, I've got to pay some money out because I'm compromised, and you can see some of these months where around 20% of your costs will happen. So this is dependent on the regulatory space, and they separated this out because regulatory space, you're paying a lot right at the end when you're highly regulated, so financial services, for example. But the average here is around 20% across all industries, low regulation, 27%. But it goes down, and what's interesting, after 21 months and you go further on, you've still got significant costs within a breach. I think I'll stop in a minute, but yeah, one thing is I'm in a university, so I'd say, more universities, actually, in fact, I remember this page because I was quoted on the front page. My boss, Lloyd Bass, sure it wasn't too targeted institution in that, but it made the front page of the Times. But everywhere, we now have direct relationship with the National Cybersecurity Centre, so we've got good understanding of the threats. In the US, there is something called Research Educators Network, which is an ISAC, an Information Sharing and Analysis Centre, which shares information. In the UK, there is something called the Joint Information Systems Committee. It runs the backbone of the internet for all universities, called GIAN, the Joint Academic Network. But it is now providing threat intel. It's got its own instance and is sharing that with universities. So universities increasingly under target. I'm going to stop there at that point for today, and we'll talk a little bit more. So I've talked in dispatches around cyber resilience and why it's important to be resilient, because we're getting attacked a lot more. What I'll do tomorrow is I'll go through the methodology for cyber resilience, which is a different approach, and it brings in some of that AI, it brings in some of that reactive nature. There'll be elements there around zero trust that I'll talk about as well. Okay, but for now, thank you very much.
I have a question.
Oh yeah, okay.
So actually, sir, as we know, ransomware attack on stages, right?
Sorry?
Ransomware attacks on stages.
Yeah.
So how can we design a system which can detect or prevent attack at early stages?
Okay, so there is a startup right now that's trying to, what it's trying to do is at early stage determine the keys. So with a ransomware attack, typically, what it does is it will take your assets and encrypt them, yeah? And what it's trying to do is look at that encryption element. How exactly it's working, I'm not sure. One thing, you know, so I know when the WannaCry attack happened, one university that did particularly well was UCL, University College London, and one of my advisors for the University Academic Centre of Excellence was a senior person there who did really well. The NHS did really quite poorly. But for me, the thing that you need to do is, first thing you know, when you know that you're compromised, you're starting to lose access to assets, yeah, immediately think about changing your policies, right? Find out who is where, don't let them traverse any more across your network. Yeah, because typically, and especially with the NHS, it was loads of distributed systems that were being targeted, right? So the first thing you do is you've got to, you know, be on high alert. So that threat intel that you're with zero trust. The next thing you do is, if systems are down, yeah, you have to have resilience. You have to do some kind of agreed process. So some business continuity planning, disaster recovery management. So what you have to do is you have to bring those in. And then finally, as part of that process, you know, so what I would be doing is saying, right, what we're going to do is that system and that data is all gone. But what we do is we have data that we had, which was our last known good data. Yeah, we're going to use that, and we're going to separately have new data coming in. So for the NHS, that was new appointments, for example, yeah? So what you do is you say, right, we're going to do that, but you don't allow write access. Yeah, because somewhere somebody is getting into the system and encrypting. If they're just reading, that's okay, you've still got your asset. Problem is if they write it, yeah, so that your asset is there, but it's encrypted. So what you do is you prevent all write access, and you have the second thing. So what I'd have done with the NHS is essentially had my system that was unavailable, but I'd have started almost a new system with write access, with read access only, a managed process. So you have very thin clients to see what was already in there. You've got a problem that there might be conflict, right? If you're not allowing write access, you have to live with that. It's going to be part of your process to say, look, we're going to have to, for a while, have these potential conflicts in data. You can't do your data deconfliction at that point if you don't have write access. So you do as much as you can in a manual way or some other way, but you've got to prevent write access to your original data. Okay. Thank you. Thank you. Oh, you found an adapter with UK plugged in it?